Good morning students. We are discussing on pavement design and highway construction. In today's lecture, we will discuss on few new technology, that is the cold mix technology. Well, in India for decades, hot mix asphalt with the bitumen aggregate has been used as a pavement mixes. The wide use of hot mix technology leads to environmental pollution as such plants have emit a huge amount of greenhouse gases. Hot mix asphalt also works favorably with the certain environmental conditions. These plants are sometimes purely non-functional at the time of rainy season. So we have to overcome from such problems. So for that, other hand, there is another technology, that is cold mix technology, and it is a pavement technology that is without heating the aggregates and using the cationic bituminous emulsion. The usage of cold mix bitumen emulsion in India is a sustainable technology and it is ideal in the country as the use of bitumen emulsion negates the heating of aggregates and binder. Aggregates are made wet with water and then further coating of bitumen emulsion is to be done. If we talk about the advantage of cold mix technology over the hot mix asphalt, well, there is no need of maintaining the high temperature while manufacturing and laying the mix. Also, the cold mix technology is pollution free, so it protects the environment to get harm and low risk for the laborers also as the working conditions are not extreme. Also, this technology is favorable to the work in all different weather conditions. You can also use this technology in the hot weather. Also, you can use it in the monsoon season also. This technology is energy saving as there is no heating required. Well, cold mix bitumen immersion is ideal for remote location and the rural areas. The Central Road Research is the organization in India which carries the research and development activities for safely construction of such roads by using this technology. It provides the license of cold mix across the India. So if we talk about the cold mix applications, well, we can use this technology while surface tracing, while repairing the potholes, also in the mixed seal surfacing for the patchwork and to provide a premix carpet. So in all this repair work, we can use the cold mix technology. Now, if we talk on the emulsion mix used for such technology, that we have two different types of emulsion mix that we can use in cold mix technology. The first is dense graded and the second is open graded. Well, talking about the dense graded, the aggregate used containing the fine materials and the fillers. When this mixture is compacted, there are fewer advoids to accommodate the water. In the open graded, the aggregate used in the open graded mix do not contain a very fine material, and when compacted they leave huge voids and the water penetrates through them. While talking about the premix carpeting process, in the premix carpeting process, first open grade premix is prepared in a concrete mixture. After that, the specific quantity of emulsion that is fixed with the quantity of aggregates for few minutes. So here the emulsion and aggregate will get mixed with each other. When the cold mix shows the brown color, it should be loaded in the trolleys and then dispatched for the sites of the construction. wherein now this cold mix is compacted with the help of the roller to get the premix carpeting finishing. The continuous improvement of the quality of materials that are used in the road infrastructure will lead to less deterioration of roads for a more extended period. Its usage on Indian roads has proved very beneficial because it offers the structural strength of layers. Adding to that, it is turning out to be the cost-effective solution for repairing or paving the rural roads in India. So this was all about the cold mix technology. Now the next technology, that is warm mix asphalt. Well, the basic principle of this technology is that by adding certain additives at the final stage of the mix production, the coating of the aggregates to be done by the binder is greatly enhanced, and it can be achieved at a considerably less temperature, that is almost 30° less compared to the hot mix process, wherein bituminous is get heated to a sufficiently high temperature to make the bituminous material in the fluid state, that is enough to surround the aggregate and coat the aggregate surfaces. In a hot mix process, it is the viscosity of the bitumen alone that is less at the higher temperature that plays the main role in coating the aggregates. In the warm mix technology, this can be achieved in three different ways. That can be done by increasing the volume of bitumen. That can be also possible by making the bituminous less viscous and by reducing the surface tension at the aggregate bitumen interface. Currently, there are more than 30 different warm mix asphalt technology that using patented process and products which have the capability of bringing the reduction in mixing or the laydown and the compaction. Using the guidelines cover currently adopted warm mix asphalt technology, it classifying them into four main categories, although at the end effect of reduction of mixing, laydown and the compaction temperatures are the same. The different technologies work in different ways. The additives, which are either waxes or the other hydrocarbon modifiers that improve the lubrication by reducing the viscosity of the bitumen, and it allows a reduction of 28 to 40 degrees Celsius in mixing and compaction. The typical dosage are 0.5 to 1.5% by weight of the bitumen. Sometimes additives are also added as a modifiers for increasing the stiffness of asphalt mixes for the special application such as the racing tracks, wherein the tire and the road surface will be in the high contact, wherein there is a possibility of high friction at such places. This kind of material, this kind of additives can be used. Now if we talk about the advantage of or the benefits of warm mix asphalt, the first is environmental benefit. It has a health benefit. The technical advantage is also there and cost effective also. So talking about the environmental benefits, The single most important justification for the use of this technology that it reduces the emission of greenhouse gases by around 25 to 30%. This would earn tradable carbon credit. Also, the technology is quite compatible with the reclaimed asphalt pavement, which saves the requirement of fresh aggregate, and it reduces the environmental hazard associated with the dumping of damaged material. Talking about the health benefit, the fumes from the hot mix asphalt are known to be potentially health hazard, especially for the construction workers. So reducing the temperature of mix avoids such kind of health hazard. If we talk about the technical advantage, lower mixing temperature reduces the oxidation and aging of bitumen, and thereby it gives longer lasting pavement by delaying the fatigue cracking. Much improved workability of the mix at the lower temperatures gives better compatibility and larger compaction window. The reduced rate of cooling of the mix due to the low initial temperature. The mix permits longer hold distance from the plant. Talking about the cost effectiveness, the warm mix asphalt technology is most likely to have the long-term cost advantage, though its estimation should be case specific. So it depends upon that where we are using this and for what purpose we are applying this technology. So according to that, the cost is variable. The cost advantage is a trade-off. The cost advantage is a trade-off between the additional cost of using the additives and the technologies and the cost saving achieved through reduced fuel consumption and longer life of the pavement. Now, white topping is the covering of an existing asphalt pavement with a layer of Portland cement concrete. White topping is divided into different types, that is depending on the thickness of the concrete layer and whether the layer is to be bonded to the asphalt. Well, unbounded white topping, also called as the conventional white topping, uses the concrete thickness of 20 centimeter or the more than is not bonded to the asphalt. Bonded white topping uses the thickness of 5 to 15 centimeter bonded to the asphalt pavement and is divided into two different types, that is thin white topping and ultra thin white topping. The bonded is made by texturing the asphalt. The thin white topping uses a bonded layer of concrete that is of 10 to 15 centimeter, while an ultra thin layer has the thickness of 5 to 10 centimeter. Ultra thin white topping is suitable for light duty uses such as the roads with low traffic volume, parking lots and the small airports. Fiber reinforced concrete is used in some thin white topping overlays and almost all ultra thin white topping overlays. White topping is suitable for asphalt pavement with little deterioration, although repairs can be made to the asphalt if necessary. If the pavement is badly damaged, it should be completely removed and a new concrete pavement should be installed. The pavement should be relatively hard and deterioration of overlays is significantly increased on the asphalt basis with the high viscosity. If a grade or a distance between the pavement and the bridge needs to be preserved, the asphalt can be milled so that the height of the pavement does not change. However, white topping requires the asphalt to be at least 7.5 centimeter thick. If necessary, a section of new concrete roadway can also be applied or can also be placed under the bridge with the gentle slope on either side that meet up with the white top portion of the road. So this was the white topping, the conventional white topping discussion. Now let's see how ultra thin white topping is useful. Well, PCC overlay of the thickness that is equal to or less than 100 mm is classified as the ultra thin white topping. Bonding between underlaying the bituminous layer and overlaid PCC layer is mandatory in case of ultra thin white topping. Milling the existing bituminous surface to an average depth of 25 mm is normally used to provide the bonding at the interface between the existing bituminous surface and the PCC overlay. Such bonding can be provided by some other method also, but milling is considered desirable because effective bond between the existing and the overlaid surface is absolutely essential for a better performance of ultra thin white topping. Fibers and high strength concrete are normally provided. Joints are spaced closely at the interval of 0.6 to 1.25 meter. Now if we talk about the saline features of ultra thin white topping, the development of an effective bonding between PCC overlay and the existing bituminous pavement is critical to the performance of ultra thin white topping, because the strength of the existing bituminous pavement is being relied upon to carry the part of the traffic load. So the extensive surface preparation to promote the significant bonding between the concrete overlay and the bituminous pavement is required, and that is fulfilled in the ultra thin white topping. Also, use of short joint spacing is available in this technology, and the minimum thickness of hot mixed bituminous pavement here we are taking as a 75 mm. So these three are the features of ultra thin white topping. While talking that at what location we can apply this technology, specifically this technology is applied on the overlays. Okay, so talking about the few locations where we can apply ultra thin white topping, that is on the low volume road. Also we can apply it in the parking slots, footpaths, residential streets, shoulders and the intersections. So all these six are the main location where you can provide ultra thin white topping, and it is beneficial at such location. Well, ultra thin white topping should be used only when the condition of the existing bituminous surface is fair, without any white cracks and without any material related problems. Isolated locations with distresses related to the material failure or heavy rutting should be replaced by lean concrete by full or the partial depth that repaired before the laying of ultra thin white topping. Thank you so much students for your kind attention.